Nuco has a sordid history. It was incubated within Deloitte, formerly Rubik's. So this platform concept was incubated along with the service company that Anna talked about earlier, and there was a decision made to fork them, separate them, and Nuco spun out as a platform entity. So you can think of it as what was involved in incubating this new company. So Matt is one of the founders and CEO of Nuco, and we developed this application you saw today on their platform. Again, formerly with Deloitte, Rubik's team. So I think you guys just work together. Awesome reunion. And you won't hold us against Matt, but he's formerly a chartered accountant.
I think I still have my designation.
He's way too cool to be a chartered accountant.
No, I don't.
He's way too cool to be a chartered accountant. I didn't say that. And a personal factor he shared with me, he's triathlon.
Well, you don't have to say that if everybody else did personal facts.
Well, there was one for Leanna, which I forgot to mention. It was so cool. You're part of a whiskey club, right?
She's the founder of
a whiskey club.
She's a stranger.
You want to talk to her about whiskey after. So I can hand it over to you. Thanks.
And thanks for having me. I won't be too long, but I think that was a really good segue after Anita's, because I think that she did a really good job showing kind of what's possible. So I'll tell you like a little bit about what we're doing. I'll tie it into how it starts to power the types of applications that DSpace has been building, like the Rubik's team has been building. And then I'll just kind of illustrate for you. I'm not going to get into too much depth. What are the different layers of this technology? Where is there a lot of interesting prototyping happening? And our focus being more specifically on how do you actually scale these things beyond those like early stage lab prototypes to eventually being solutions that can be rolled out to market on like a mass scale. So the question that was asked earlier, for example, how do you ensure that you can put in things like sanctions into these types of applications? Some of that happens at the logical layer of the application. Some of it will also eventually start happening at the what we use the model of like a permission access model for when you're creating these networks, being able to give authority to certain members to participate in the networks and certain members not to participate. So then you can start applying kind of rules of sanctions and things like that. So anyways, a quick intro of me. I worked for several years with Liliana. We trace back even before our days at Deloitte. But as Norm said, in the process of going through the Rubik's kind of evolution over the 2 years that I worked with Liliana on Rubik's, we came to a point of essentially forking is a good word to use, especially in the context of blockchains, where we wanted to build a scalable enterprise application or enterprise blockchain infrastructure so that applications could be built into domains of enterprise. So how do you create a set of rules and scenarios so that when somebody wants to go build a trade finance application, as an example, that involves a financier and a buyer and a seller and a government, on what network will that be built? And in some cases, these applications will be built on public networks like Ethereum directly or on the Bitcoin network. But our view had always been that there would be networks that would evolve that would be more built to purpose. And those built to purpose networks would be specifically for a group of banks who interact with each other regularly, or a supply chain that interacts with each other regularly, and be able to define the rules of those networks. So that's what Nuco is essentially. And I'm not going to spend too much time on this deck because it's more information than I have time for. But I will give you a little bit of a view, and you'll have to forgive me because this stuff's constantly in development. But I'll give you a little bit of a view of what our dashboard and blockchain environment looks like. I'll also give you a little bit of a view of a very simple use case that we developed with the Rubik's team in Toronto, just to kind of open up your mind to what this could be as we progress into the future. So this is kind of our mantra. We want to power the decentralized infrastructure of tomorrow's enterprise. This has kind of taken two folds for us. One is working with big companies today, many of whom are represented here, to help them go into this modern digital future. And then the other one is also building the base layer of infrastructure so that when new businesses emerge, they have infrastructure to build those businesses on. So kind of like an AWS model when you're going into like the web server or web application space, we're trying to replicate that model into the blockchain space. So this is how we kind of identify our opportunity as a company, is that there was all these problems and challenges in the enterprise world that were not necessarily being perfectly met by the high potential of blockchain technologies. So we said, well, how do we kind of take the best of this blockchain stuff and apply it and redesign it so that it kind of meets the specifications of a big business. So we specifically focused in on a technology known as Ethereum. We said we love the potential of this, we love the flexibility of this, we love everything that it kind of stands for, but it's got some limitations that anybody who has worked with Ethereum has probably encountered when you're dealing with enterprise applications. So this list of limitations kind of became what we wanted to solve. So that's, I won't get into them in any depth, but that's kind of where our roadmap stemmed from. And again, this is more detail than most of you will want to know or listen to, but this is just a basic view of our architecture. How do we take something like Ethereum and kind of design a modular infrastructure so that depending on the scenario, depending on the number of participants, depending on the industry and the jurisdiction, we can kind of plug and play different functionalities. What type of consensus algorithm makes sense? How many participants? What type of performance needs to be on that network? If I'm talking about very occasional exchanges of illiquid private equities, that's a very different type of network that will be required than if I'm talking about high frequency traded public equities in the United States, for example. So these different specifications mean that in our mind, there's not going to be a one-size-fits-all off-the-shelf blockchain infrastructure to solve everything. So we wanted to create an infrastructure that was customizable because it is modular. So that's what we're in the process of designing. We're kind of halfway through this 9-month roadmap, coming close to our 3rd milestone. But anyways, these are kind of details that are not all that relevant. We have kind of 3 approaches to go to market. One is working directly with big established companies that are in the process of doing prototyping for themselves in labs. And that means, they, in many cases, need a technology to do their prototyping on. So we make this, our stack available, our test network available to these types of clients with the eventual goal of helping them scale those solutions. Our second kind of go-to-market is, the relationship we have with Deloitte was kind of what spurred this, was building and going to market through partnerships with established businesses that have kind of access to different verticals than we do. So Deloitte is a great example of this. On the infrastructure side, working with companies like Amazon Web Services or IBM, and eventually going into the ERP space because we think there's a natural extension from what these database providers do to what a blockchain will eventually be. So this is kind of one of our scaling models that we're going after. And then thirdly, as I said, is this kind of AWS business model where we actually want to become that underlying technology leveraged by other startups as they scale. So we're being extremely selective right now. We're a very early stage company. We officially started in May. Really, we started scaling the team in July, August. But when we go look for partners to work with in the startup space, we're looking for kind of well-funded companies that have a really, really interesting idea that is kind of applicable to a particular enterprise market, where they also have an infrastructure requirement, and we're essentially selling them on the fact that we can build your infrastructure better than you can, so you stay focused on your application, we'll come in and solve the infrastructure requirements. So we're starting to do that with a US blockchain company in the healthcare space primarily, a British blockchain company in the finance space primarily, a local Waterloo company in the IoT space. So this is kind of one of our scaling models. If these companies have success, then they will be dragging our technology along with them, which is fantastic. So, and very simply, most of this stuff is open source. We're starting off with open source components. There are functionalities that we're building that will be proprietary and that we will license in certain circumstances. So this is what our business model is. I don't want to jump into, let me pull up a screenshot. So because I think we kind of skipped over the assumption that everybody knew what a blockchain was at the beginning of this afternoon. So I'll step back and just kind of show you, and again, I actually showed this to Ileana about 3 hours ago, and it looked different because our team's in the process of putting in place a new UX. So this is kind of like a network view of what our blockchain is doing right now, and you have to forgive me if it's lagging. But just so that everybody has kind of an understanding, Danita made reference a couple of times to how the front-end application that they were building kind of ties into a network behind the scenes. So, there's one thing that has to do with like participants in an application, and then the other layer that we're more focused on is how do you actually design the decentralized infrastructure that it sits on. So a blockchain can very simply be described from our perspective as decentralized infrastructure. So multiple parties kind of maintaining a common infrastructure as a public utility in that scenario. So it could be in finance, it could be in healthcare, whatever. So what you see here is kind of a view of the real-time blocks being added with some lag, I'll admit today, but with the functionality to be able to go back into transaction histories and prove that they happened on this chain at some point in previous history. So this blockchain that we're operating is our test network. if I go pull up, so this one I think is operating right now on 8 nodes. So these are our servers that are sitting in the IBM cloud primarily. We also have one on the AWS cloud sitting, for example, in the US, in the Netherlands, in London, in Melbourne, Australia, Hong Kong. So what we're trying to illustrate here is that you can create these kind of controlled environments, these private networks that are still decentralized around the world that might be able to tie together, a financial organization that has potentially branches or divisions in different parts of the world that needs to transact with each other more regularly. We're starting to work with a Spanish bank on an internal settlement process that they have a challenge with, which has nothing to do with leaving the actual walls of their company, but it has to do with the fact that they have operations in about 25 countries around the world and they transact with each other in multiple currencies. And right now, when they go from Spain to Portugal with a transaction, on their current infrastructure, it literally is faster to put cash into a truck and drive it across the border than what they currently can do. So they're starting to experiment with what does a blockchain within our own organization look like. So what we're doing here is essentially saying, well, you can set up a network however you want. That network can be built on any type of infrastructure you want. So we're using primarily cloud infrastructure because it's easier to get going. So we're going to be moving towards as diverse a cloud infrastructure base as possible. So we're working with IBM and AWS primarily. We have done some experimentation on Microsoft Azure, the Google Cloud. We're going to start working with some Chinese cloud providers. And then also more on-premise traditional server infrastructure that might be used in a lot of these big businesses or governments that already have their server infrastructure behind the scenes. So the point is that this kind of sits one layer above that and then connects all of these multiple organizations on this peer-to-peer decentralized network. The other kind of cool thing that we can start doing, and we're just starting to play with these functionalities, but is start to provide kind of interesting analytics about the type of transaction throughput and the type of participation you're seeing on the network and the efficiencies that you're gaining by doing things in a decentralized way versus in a more traditional fashion. So, we started playing with 2 or 3 kind of analytic tools, but the goal being that over time you can really get some meaningful insights and, pull stuff out of the data that would not previously been all that simple. And one of the really interesting opportunities here is when we think of regulated industries and we think of the role that the regulator themselves will want to play, and I'll walk you through a use case that we're in the process of building right now, it starts to give a government or a regulator more direct access into seeing what's happening, especially from a compliance perspective. Where we think of compliance today as kind of a retrospective thing that you do at year end and that a government will potentially come audit you on. This is maybe giving a seat at the table for a regulator to see compliance happening in real time. If you can set the rules into the network and then eventually set the rules into the application sitting on that network. So that's a simple view there. I did want to walk you through, so I'll do this one really quick. This is one that we worked on with the Rubik's team at Deloitte. And then I'll talk to you about another one briefly because I think it's interesting. So this is a very, very simple use case that we designed for primarily a US audience around the problem dealing with prescription drugs and fraud that happens in prescription drugs. So right now there's a big problem in the US around if I get a prescription printed from my doctor, I can quite simply photocopy it and go to 2 pharmacies and get the prescription twice. Or I can go with the same symptoms to multiple doctors and get multiple prescriptions for the same symptoms. And this feeds into a problem of black market drugs and overdoses and big cost in the healthcare system. So we wanted to build a very simple, this probably took us a week and a half, 2 weeks to throw together. We brainstormed this with the Rubik's team to essentially show, well, in addition to the systems that these pharmacies and clinics currently use, what could you do on top of that to take advantage of this concept of decentralized infrastructure? So on the left, if you work with me here, in the blue, is kind of an add-on functionality that we envisioned for the doctor. And on the right is a scanning functionality of the pharmacy. So keep in mind that in most jurisdictions, you're talking about doctors that are coming from a multitude of companies and clinics and hospitals that have no reason to share infrastructure with each other. And similarly on the right, you have all sorts of private entity pharmacies that also have no reason to share infrastructure with each other. So how do you make sure that if somebody gets a prescription at Dr. A, they can't go to pharmacy 1 or pharmacy 2 and get the prescription twice. So very simply, and this is happening on the network that I showed you, so it might actually be kind of slow today. This is a very simple prescription form that you might get when you leave a doctor's office. And what we wanted to show was, taking that prescription, bringing it into some sort of web-based interface, adding a unique characteristic that can be recorded to the blockchain. So by creating this QR code before printing the document that I'm then giving to my patient, I've actually essentially attached to this prescription a unique characteristic that can be traced back to a smart contract sitting on our blockchain. So what this is going to allow me to do is that when somebody then takes that prescription, even if they photocopy it 100 times, the first time it gets scanned, it will essentially nullify its ability to ever be used again. Because then that scanning of the QR code will send another message to the smart contract to say, this has already been redeemed. So the next person to scan it say, no, don't give this guy any drugs, he's already redeemed this somewhere else. So that's kind of the functionality we were working with. And this very, very same use case can be used in a multitude of industries. We're using prescription drugs as a very simple example. I'll see if it has, so this is the transaction here at the top, and you'll see it's still in processing mode, which means that it hasn't been added to the block yet, but I'll jump to the second one to continue the demo. So the second one is one that's already been processed and has not been dispensed. So if the pharmacist were to scan this, it would say, okay, yeah, you're good to go, give this guy your drugs. It spits out some very critical information like what was the name of the drug, what's the quantity of the drug. And then essentially the pharmacist clicks ready to dispense. And then it sends another transaction back to the smart contract to say, I've used this one. Okay? So over time, let me see how quick our blocks are right now. I think they're going pretty slow. Yeah, so we won't wait for this because it's going too slow. But essentially what you'll notice is these two statuses here, processed and dispensed, would essentially change as the block gets mined from processing to processed and from not dispensed to dispensed. So if I jump to the third one to continue the demo, this one's been processed and dispensed. So if this guy went back to a second or third or fourth pharmacy, you'd be told, sorry, you can't take this drug out anymore. And then essentially we've stopped the possibility of someone taking out a fraudulent prescription. And this is like a $5-point-something billion problem in the US, 25,000 annual deaths from prescription drug overdoses caused by people going and getting illegally sourced prescription drugs. So really, really simple use case. I mean, the goal here was just to show like the simple functionality. Another one that I thought was kind of cool, that I might have a visual diagram on without actually having it built, is a use case we're building in Ontario with a software vendor that is, software vendor that's in the payday loan market. So as many of you know, payday loans are kind of a sketchy market, to say the least. But the government is really making a big effort to put some structure and some regulations around this market. And one of those regulations that's currently being considered for legislation is one that would essentially restrict the ability, for an individual to maintain more than one loan at any one time. So if I go to Money Mart and take out a $200 payday loan, and then I go to Cash Money and do it again, and there was actually cases of this where people would essentially drive down the 401 and just hit up payday loan vendors and get 30 loans in one day with very little need for documentation or proof of evidence, and then they'd go to like a bankruptcy liquidation expert and they'd get the whole thing kind of wiped out in court that they've already taken up this money. And for one, it was causing an enormous consumer debt problem, and two, people were taking advantage of the system because there are literally businesses that help you get out of these debts. So the government's considering a legislative change that would essentially restrict somebody from maintaining more than one loan at one time, and put in place something in the middle called a cool-off period, saying, after you pay off one loan, we want you to just chill for a few days before you go get another one, just to get people out of this cycle of dependency on these loans. But the problem with that type of regulation is that there's no real way to enforce it. There's kind of two ways that we could imagine enforcing it. One would be, let's create a centralized government database where all of these transactions have to be kind of promptly on a daily basis be submitted to the government, where you still have some possibility of not having real-time oversight, but you also create a new kind of bureaucratic requirement at the government level. Or why don't we build a blockchain? In Ontario, there are 796 payday loan providers, all of which are competitors to each other, some extremely large companies like the Money Marts, and some are mom and pop corner stores that just offer this as a service. So how do we make like a really low touch solution that says if I have a loan and I just want to kind of record the issuance of that loan in a relatively high level way, I don't need to give away amount or name of the person or anything like private or competitive, but I can put it in a place that when somebody else goes, very similar to the prescription drug, somebody else goes with a similar characteristic to get another loan, they're blocked. There's already a loan in the system associated to a hash of your driver's license or of your passport or whatever type of identification you're using, and make it really, really simple for the government to kind of enforce these types of regulations, which are important in certain contexts. So I mean, this is kind of a simple process flow that we walk through in the proposal of that use case. But so that's kind of all I wanted to talk about. I mean, I'll jump back to my slide deck that I had earlier. You know, this is I give them credit while I'm here. This is my founding team and our board of directors and advisors. We're in the process of hiring more people. I haven't spent as much time in Waterloo as I probably should, considering the pool of talent here. We're based in Toronto. We're now day in about 11 or 12 people in the office. We've got a couple of kind of floating interns. And we started in May, so we just finished raising money over the last few months. And you know, things are going really well. There's a lot of excitement around what we're doing. We're extremely fortunate to be here and excited to be here, and obviously excited to be working with the likes of Curelet on this type of stuff. So that's all I've got for you. I hope you enjoyed that. I'd be happy to answer any questions. Yeah. Did you have questions?
Yeah, I have a whole bunch. When it comes to the technology, it's like pretty sketchy and hard to find. For somebody as green as myself, I've got like the experience in the blockchain area.
Yeah.
Where would somebody start? Like, what's a good resource to start in terms of
To learn, you mean?
understanding it? I know there's the papers, the white papers, but in terms of actual platforms or development tools.
I think for that's a great question. I think if you have any kind of technical capabilities, probably the best way to start is just to get your hands dirty on some code. And I mean, the easiest I've found for people that are trying to get into the space of learning how to build something on a blockchain is usually people gravitate towards Ethereum. It's a relatively simple solution to start using. You can build kind of test environments on Ethereum. All sorts of online documentation, how you get set up and how you get started. You can start writing smart contracts in kind of a test environment. So that's probably a good way to do it. There are a ton of variations of this technology. You know, we often talk about blockchain and you hear these analogies to the internet. It's actually quite different because we're not talking about one technology. We're talking about this umbrella category of technologies that encompasses a whole variety of things, many of which don't actually call themselves blockchains, but they've been encapsulated, like the examples of like Ripple and R3's building software called Corda. They will tell you actively they are not building blockchains, but they still get kind of bundled in. So if you want to get some cross-the-board visibility, then you generally have three, I'd say, major categories of technology. One is Bitcoin or technologies that were derived from Bitcoin. So there's a lot of technologies that started as kind of forks of Bitcoin. Simple analogy that I like to use to compare the two with Bitcoin and Ethereum. Bitcoin was kind of like this, we use the Google Doc analogy. So if you're looking at like a Google spreadsheet, shared database where you can write transactional inputs and where you can change kind of ownership of assets in a way that is kind of transparent to everyone. So that's kind of one technology that's really good at value transfer, really good at kind of exchanging of tokens. So there's that and its derivatives. Ethereum, the analogy is that if you take that same spreadsheet and you say, well, now add kind of Excel-based formulas into every cell so you can start adding intelligence and logic to the spreadsheet, then you've kind of built like an Ethereum model. It's a little bit more intelligent and can allow you to do a little bit more complex things, which in some cases is necessary, some cases is not. So then there's Ethereum, the public network, and then derivatives of that technology. So we probably fall into that category, derivatives of Ethereum. And then the third is like built from scratch for purpose, from the ground up. IBM has built its own infrastructure. R3 has built its own infrastructure that didn't necessarily take existing functionalities from either Bitcoin or Ethereum. And there's others out there, but these are generally the three major categories.
They just had some commentary. So
Sure.
when our lab did our proof of concept, it just came in as a new project. Hey, let's do a blockchain project. Okay, what do we start? So we did that last April-ish, May. So we've gone from 0 to what we showed today in about 5 months. So maybe you need a couple tips you can share.
I think it's so for us the biggest thing figuring out was how to send an event. Like what does that mean? And how do I do that? So just getting started with the minimal, like the simplest example that's out there, and then run it and try to logically think why it is, how it is in blockchain, and how it is different from the existing applications right now. Because what we try to do is we try to superimpose what we are used to right now. Like I need to have a name with this account because that's how we understand things right now. I need a login. But then if it's in blockchain, and if you're saying that this is a trustworthy permanent record, and people have this misnomer as well, like Bitcoin, you can never go back and see who did it, right? Like we cannot find that person, which is a big misnomer because all that trail is there. So yeah, so that was for the co-ops as well. So this whole thing that we have built, we had 4 co-ops working on it too. So this is completely new for them. So yeah, so just trying to figure out, so breaking down into different problems. There are so many options out there. If you start looking out, it's like so easy to get lost, but eventually what we want to solve and what are our outcomes with it. So that we had like pretty solid outcomes which were written, and we would go back to them again and we would be like, are we there? And then we would have these constant, so we have HR. So we had these constant demos with the business team. So they would set up priorities again. So if we go back and get to techie or geeky and we want to do this because this is so cool, they would get us back and they'd be like, okay, no, that this is the problem we want to solve. So yeah, so from the technical side, trying to solve the smallest problem and then make it bigger. So as an architect background, that was a bit different too for me, because as an architect, you see the problem and you try to build the whole thing and then you build the solution. But here in blockchain is different because the technology is changing so much, you cannot build the whole thing and then.
And I think one of the things when you're learning about why a blockchain is different is it's really more teaching yourself a new way of thinking rather than a specific hard skill set, because the hard skill set will change depending on what type of blockchain you're using and things that haven't even emerged yet. I mean, we're working off of the Ethereum. Ethereum right now, when you build smart contracts, it's a new language called Solidity. So everybody's okay, well, I got to learn this new language, I got to learn how to use Solidity. But eventually people will be writing smart contracts in non-Solidity languages. So then the important thing is not knowing Solidity, it's knowing how the framework works and why it's different and why it changes business models, etc. And then you can kind of adjust with, you find many people come into this space with already having a background of some sort of, computer science or engineering background. And there's definitely ways for, if you're a C++ engineer or you just have experience in Java, JavaScript, or Python, or whatever, there are all sorts of different implementations of blockchains where you can find a way to use whatever background and skill set you have to make an implement. But it's more of a mindset, like if you always say, approaching things differently.
It is still in such an infancy. I envision that when it really does take off, there's going to be blockchains everywhere, right?
Yeah, it hasn't. We were talking about this earlier. It hasn't quite hit that mainstream attention that many other kind of emerging technologies. You talk about artificial intelligence or machine learning. These are much more mainstream now in terms of their acceptance. The fact that there's a ton of people kind of focusing on that in their for their careers. This hasn't even quite hit curriculum level at universities like the University of Waterloo. I mean, I kind of joke about this because Vitalik, who's here, he's a dropout from the University of Waterloo. He's probably one of the most infamous or renowned people in the blockchain space in the world, and he was partially educated right here in Waterloo, and nobody really knows who he is. But he's behind like a $1.4 billion technology that was the brainchild of some time he spent here. So I kind of, there's a lot more awareness that needs to happen, a lot more of these types of sessions that need to happen. And then like you, just go and learn, go down, go find something online and try it out.
Most cities also have communities or local meetup groups where developers will get together, and in Toronto there's one that happens every 2 weeks on Friday. Right now they're building a prototype to dispense beer using smart contracts and a Raspberry Pi tool. So it's good to find those groups because you'll do a lot of the joint learning there.
So, unless there's any really burning questions that you just need to answer in the public forum, I think all the speakers will hear in a few minutes. But thank you for your patience. We've been a little over time today, but I think thank you to all the speakers for the